Hello, we are from Group Epsilon. Today, we are going to discuss the topic about matrices. First of all, let's recall back how to find the determinant of a 3 by 3 matrix. Let Z be a 3 by 3 matrix. The determinant of Z is the sum of the product of elements in the ith row and j column with the cofactor in the ith row and j column where I equals to 1, 2, 3, and so on until n, and j equals to 1, 2, 3, and so on until n. Let us understand the concept of minor. Minor of the element in ith row and j column of a matrix can be obtained by deleting ith row and j column. For example, the minor in the first row and first column can be obtained by deleting the first row and first column. Deleting the first row and the first column, we left only a 2 by 2 order and use the concept of AD minus BC, where A multiplied with D minus B multiplied with C. Similarly, the minor in the third row and second column can be obtained by deleting the third row and second column. Deleting the third row and second column, we left only a 2 by 2 order and use the concept of AD minus BC, where A multiplied with D minus B multiplied with C. Next, cofactor. Cofactor equals to -1 to the power of sum of I and j multiplied with its minor. This means that the cofactor is either positive or negative minor, and the cofactor can be written as this. Can you see here? The positive and the negative sign is alternating. Let us continue with the previous example. By expanding on the first row, write down the formula of the determinant, where the determinant of Z equals to A11 multiplied with C11 plus with A12 multiplied with C12 plus with A13 multiplied with C13. By referring to the minor at the right corner, we can substitute the minor into the cofactor in the equation. Next, by expanding on the first column, write out the formula where the formula of determinant of Z equals to A11 multiplied with C11 plus with A21 multiplied with C21 plus with A31 multiplied with C31. Substitute the respective minor into the cofactor in the equation. For your information, in finding the determinant, you may expand along any row or any column. Given the question is, if matrix A equals 7, -4, -6, 2, 0, -3, 1, 2, -5, and matrix B equals to 2, 13, 0, 0, -1, 2, 1, 0, -3. Show that the determinant of the multiplication of matrix A and B equals to the determinant of A multiplied with determinant of B. First and foremost, find the multiplication of two matrices A and B. Since the number of rows of matrix A equals number of columns of matrix B, then we can perform the multiplication. Substitute matrices A and B and perform multiplication. Substitute matrix A and substitute matrix B and perform the calculation, and the multiplication of matrices A and B equals to 8, 95, 10, 1, 26, 9, -3, 11, and 19. After this, we can find the determinant of multiplication of matrices A and B. By expanding the first column, write the formula of determinant, where the determinant of multiplication of matrices A and B equals to A11 multiplied with M11 minus A21 multiplied with M21 plus with A31 multiplied with M31. Substitute the respective element A in the equation. Substitute the respective minor by deleting ith row and j column. For the first minor, deleting the first row and the first column. For the second minor, deleting the second row and first column. For the third minor, deleting the third row and the first column. Then, perform calculation on minor using the concept of AD minus BC. Simplify and perform calculation on next, and finally, we found out the answer equals to negative 320. Next, we have to find the determinant of matrix A. By expanding the second row, write the formula of determinant of matrix A, where the determinant of matrix A equals to negative A21 multiplied with M21 plus with A22 multiplied with M22 minus A23 multiplied with M23. Next, substitute the respective element A. Then, substitute the respective minor by deleting the ith row and j column. For the first minor, deleting the second row and the first column. For the second minor, deleting the second row and the second column. For the third minor, deleting the second row and the third column. Next, perform calculation on minor using AD minus BC. Then, simplify and perform the calculation on next. And finally, we will get the determinant of matrix A equals to negative 10. After this, we have to find the determinant of matrix B. By expanding the first column, write the formula of the determinant of matrix B, where the determinant of matrix B equals to A11 multiplied with M11 minus A21 multiplied with M21 plus with A31 multiplied with M31. Substitute the respective element A and substitute the respective minor by deleting ith row and j column. So deleting first row and the first column for the first minor, deleting second row and the first column for the second minor, deleting the third row and the first column for the third minor. Next, perform calculation on minor using AD minus BC. And simplify and perform calculation on next, and finally we found out that the determinant of matrix B equals to 32. We have to find the multiplication of determinant of A and determinant of B. Substitute the determinant of A and determinant of B and perform multiplication, and finally the answer equals to negative 320. Since the left-hand side, which is determinant of multiplication of matrices A and B, equals to negative 320 equals to determinant of matrix A multiplied with determinant of matrix B equals to right-hand side. Therefore, the determinant of multiplication of matrices A and B equals to determinant of matrix A multiplied with determinant of matrix B is shown.